All right, let's go ahead and begin with problem number 1, where we're going to solve this equation. Okay, so let me remove this. All right, starting with problem number 1, we're going to solve this equation. So this will be 7 times the quantity, x minus 8, and then plus 18 is equal to 3 times the quantity, x minus 6. And here we're going to solve this equation for the variable x. Okay. So the first thing we need to do here is just remove the parentheses and combine some like terms here. Now, on the left side, if I distribute the 7 over the x minus 8, I would get what? 7x minus 56. Then we bring down the plus 18, and then that's equal to 3x minus 18. Here I'm distributing the 3 over the x minus 6. And then let's see if we can combine some like terms here. We got 7x now. Minus 56 plus 18 is what? Negative 38. So you got 7x minus 38. And that's equal to 3x minus 18. The right side is already in simplest form where we've already got something simplified. All right, now let's get all the x's preferably on the left-hand side. Or try to move the variable that has the smallest coefficient over to the opposite side. Let's move the 3x over to where 7x is by doing what? Subtract 3x. So that means I have 7x minus 3x, which will be 4x minus 38. That's equal to negative 18. And do not forget to bring that negative sign in front. Some students do this all the time. Bring this down and not bring down the negative in front of the constant term. Now to get 4x by itself, I need to do what? Add 38 to both sides. So now you got 4x is equal to 20. And then to get x by itself, I need to divide by 4. So x is equal to 5. Now I didn't say check, but if you do have the time, you can check your proposed solution. So here x will be equal to 5. All right, questions on problem number 1. All right, number 2. Here we got x plus 8 divided by 5 minus x plus 4 divided by 2 is equal to 7/20. Now in this problem, we got constant terms in the denominator. So that means we need to find the least common denominator of those numbers here. So the least common denominator for 5, 2, and 20 is what? 20. That's the smallest number that's divisible by 5 and by 2 and by 20. So that means here we're going to multiply every single term in this equation by that LCD of 20. So 20 will be multiplied by x plus 8 over 5, then minus 20. That's going to be multiplied by x plus 4 over 2, and that's equal to 20 will be multiplied by 7 over 20. All right, so now let's simplify this. If I divide this 5 into 20, that's going to go 4 times. So I'm going to have 4 times the quantity x plus 8. And then minus. If I divide this 2 into 20, that's going to go 10 times. So I have 10 times the quantity x plus 4. And that's equal to, these 20s divide out, you're left with 7. So in this case here, I got 4 times the quantity x plus 8 minus 10 times the quantity x plus 4 equals 7. The left side, I need to remove some parentheses and combine like terms here. If I distribute the 4 over the x plus 8, I'm going to get what? 4x plus 32. Now, if I distribute the minus 10 over the x plus 4, I would get what? Minus 10x and a minus 40. Keep in mind the minus sign, when you distribute that, it's going to change the sign of every single term in the parentheses to the opposite. So I got 4x plus 32 minus 10x minus 40 is equal to 7. Now let's combine some like terms here. 4x minus 10x will be negative 6x minus, plus 32 minus 40 would be minus 8. That's equal to 7. And to get negative 6x by itself, I need to add 8 to both sides. So that means negative 6x is equal to 15. And then to get x by itself, I need to divide by negative 6. So that means x will be equal to, negative 15 over 6. But if I ask for you to give your answer in simplest form, it would be what? Negative 5 over 2. Because the largest number that goes into 15 and 6 will have to be 3. So the x equal negative 5 halves. So I will tell you this, you may need to reduce your fraction in simplest form whenever necessary. Are there any questions about example 2? Number 2, by the way. All right, number 3 is a rational equation where you have variables in this denominator. So we got 2x over x plus 3 is equal to 9 minus 6 divided by x plus 3. And that question would be in 2 parts. The first part, you're going to identify the restricted value. The second part is, keeping the restrictions in mind, solve the equation for that variable. All right, so let's first find out what the restricted value is for this equation. Now notice we only have the x plus 3 in the denominator, so we'll just take that and set that equal to 0, because we want to find out what value of x will give us a 0 in the denominator. So if x plus 3 equals 0, what must x have to be equal to? Negative 3. So the restricted value in this case will be x equal -3. Now, keeping in mind that x equal -3 is my restricted value, we're going to solve this equation. Well, we only got x plus 3 in the denominator, so that will have to be the LCD. X plus 3. And in this case here, we're going to multiply every single term in this equation by x plus 3. So the x plus 3 will be multiplied by 2x over x plus 3. That's equal to a number, bring down the 9. That 2 will be multiplied by x plus 3 minus the 6 over x plus 3 will be multiplied by x plus 3 as well. All right, the next step would be to go ahead and simplify this. These x plus 3's divide out. We're left with 2x. And that's equal to, if I distribute the 9 over the x plus 3, I would get what? 9x plus 27. And then minus, the x plus 3's divide out on this as well. So we have minus 6. So we got 2x is equal to 9x plus 27 minus 6. Now combining like terms here, bring this 2x down. And that's equal to, bring down the 9x. What's 27 minus 6? 21. So we got 2x is equal to 9x plus 21. And I'm going to go ahead and move the 9x over to where the 2x is. By doing what? Subtracting 9x. So here 2x minus 9x will be what? Negative 7x, and that's equal to 21. And then to solve for x, I need to divide by negative 7. So x is equal to negative 3. Is x equal to negative 3 my restricted value? Yes, it is. If that's the case, we eliminate that altogether. So that means that this rational equation has no solution. Now, don't think on the exam you're going to expect to get an equation where the answer is going to be no solution. You want to go ahead and solve for the variable and check to see if that x value is your restricted value. If it's not, then that means x equal to whatever would be your solution to that rational equation. Okay? Any questions on problem number 3? Okay, number 4 is this. Here we're going to solve the quadratic equation using the square root property. Okay. Now keep in mind on the exam, you will be given directions, specific directions on how to solve those quadratic equations, either by using the square root property, or by completing the square, or by using the quadratic formula. Okay, keep that in mind. In this case, number 4, you're told to use the square root property. So if you use anything else, that problem will be marked incorrect because you're not following directions here. So now to get x squared by itself in this equation, what do I need to do first? Add 147 to both sides. So here I'm going to have 3x squared equals 147. And then to get x squared by itself, I need to divide by 3. So x squared is equal to 49. Now, the x is being squared, so the opposite of squaring something would be to take its square root on both sides. And what do I need to include? Plus or minus. So that means x will be equal to plus or minus 7. And you can leave your answer like this if you like. Or if you want to, you can write it as two separate answers. Doesn't matter, x equals 7 or x equals negative 7. All right. Any questions about problem number 4? Okay, it does say solve the quadratic equation using the square root property. Now in number 5, you're told to complete the square in order to solve this quadratic equation. Here you got x squared minus 2x minus 5 equal to 0. So here we got x squared minus 2x minus 5 equal to 0. And in this case here, to complete the square, we need to move the constant term over to the opposite side. So here we have a minus 5, so I need to add 5 to both sides. So that means I have x squared minus 2x is equal to 5. Now we're going to complete the square. And the way we complete the square is this. You always take 1/2 the coefficient of x and then square it. And whatever you get for that, you're going to add that constant to both sides of this equation. So off to the side, I'm going to do this. 1/2 the coefficient of x, which is in this case negative 2, and that's squared. Now what's 1/2 of negative 2? Plus negative 1. Now what's negative 1 squared? 1. So in this case here, I'm going to be adding 1 to both sides of this equation. So I'm adding 1 to the x squared minus 2x, and I'm going to add 1 to this 5. The left side is a perfect square trinomial that I can factor as this, as the square of a binomial. The x squared, I know is going to be x, and if I take 1/2 of 2, that's going to be a 1. Now, the middle term has the sign of a minus, so that means I need a minus sign here. So the x minus 1 quantity square. And that's equal to, what's 5 plus 1? 6. All right, so now we can use the square root property. That x minus 1 is being squared, so what's the opposite of squaring something? Take the square root on both sides. And I need to include that plus or minus symbol, as always, when you take the square root on both sides. Now the square root of x minus 1 quantity square, the square root and the square are inverses. You'll be left with just x minus 1. That's equal to plus or minus the square root of 6. Now I need to get x by itself by doing what? Add 1 to both sides. Which means x is equal to, and I'm going to put the 1 in front of the plus or minus square root of 6. Those are two totally different terms. Because the 6 is underneath that radical. So here I just leave it as this. 1 plus or minus the square root of 6. Or if you want to, you can write this as two separate solutions. 1 plus the square root of 6. The other one will be 1 minus the square root of 6. Okay. Are there any questions about problem number 5? Okay, number 6 is solving the equation using the quadratic formula. Okay, so here you have to use the quadratic formula on this one. Here we got x squared minus 13x plus 40, and that's equal to 0. And here I want to solve this quadratic equation using the quadratic formula. So that means here I need to go ahead and identify A, B, and C. Since this equation has a 0 on one side, that tells me it is in general form. The A is the coefficient of your x squared term, which is 1. The B is the coefficient of x, which is negative 13. The constant term is 40. And our quadratic formula, it's best to write this down as this x equal negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Include that in your one-page sheet of notes. Now let's do our substitution here. Bring this x down, that's equal to, b is negative 13, and I've already got the negative in front, so it'll be negative of negative 13 plus or minus the square root of, b is negative 13, and that's square, minus 4 times a, which is 1, times c, which is 40. And all of this is divided by 2 times a. And a is 1, so it'll be 2 times 1 in the denominator. So now let's simplify what's underneath, what's in the numerator. Negative of negative 13 is just 13, plus or minus. What's negative 13 squared? 169. Negative 13 times negative 13. Minus, what's 4 times 1 times 40? 160. All that's divided by 2. 2 times 1. So here x is equal to 13 plus or minus. Now what's 169, with the square root of, what's 169 minus 160? 9. All that's divided by 2. And what will be the square root of 9? 3. So I got x equals 13 plus or minus 3. All that's divided by 2. Now that tells me I do have two solutions here. Now I will write this as x is equal to 13 plus 3 over 2. And the other one will be x equals 13 minus 3, all divided by 2. What's 13 plus 3? 16. And what's 16 divided by 2? 8. And then for the other solution, 13 minus 3 would be 10. 10 divided by 2 would be 5. Those are my two solutions for this quadratic equation, 8 and 5. Okay. Are there any questions about problem number 6? So with these quadratic equations, make sure that you follow the directions on how to solve them by either the square root property or by completing the square or by using the quadratic formula. So that's number 6. All right, number 7 is a radical equation where you must solve, and not only that, you have to check your proposed solutions here. Very important here, because you might get what they call an extraneous solution. So in number 7, we have the square root of 10 minus 3x, and that's equal to x. Square root of 10 minus 3x is equal to x. And here I want to solve this equation. And it's a radical equation because of the square root. All right, first of all, the square root is already by itself. So I don't have to worry about moving terms over to the opposite side. Now, what would be the opposite of taking the square root? Square. I need to square both sides of this equation. Because when you square both sides, you're going to eliminate that square root symbol. Because square root and square are inverses. You'll be left with what's underneath that square root symbol. That's the 10 minus 3x. And that's equal to x squared. Now we have a quadratic equation, so that means I need to get a 0 on one side of this equation. Let's move the 10 minus 3x to the opposite side by first adding 3x. And then the 10, I'll move that over by subtracting 10 on both sides. So here I'm going to get a 0 on this side, and then on the right side I get x squared plus 3x minus 10. Let's see if we can factor this into two binomials here. The x squared breaks up as x and x. Now what factors of a negative 10 will give me 3x as a middle term? 5 and a negative 2. So this will be plus 5, and the other one will be minus 2. Keep in mind that the larger of the two factors takes the sign of the middle term. So the x plus 5 times x minus 2 equal to 0. And then we set each binomial factor equal to 0. So x plus 5 times x minus 2 equals 0 means this. Either x plus 5 is equal to 0 or x minus 2 is equal to 0. And then for each equation, we will solve for x. So for the x plus 5 equals 0, what must x have to be equal to? Negative 5. Or for the x minus 2 equals 0, what must x be equal to? 2. Now, of course, the highest exponent in that radical equation is a 1. That means one of these is the actual solution to that radical equation. So this is where you do the check. And I'll start with x equal negative 5. Using the original equation, I'm going to substitute each x with negative 5. So here I'm going to have the square root of 10 minus 3 times x, which is negative 5. I want to know if that's going to be equal to negative 5. Minus 3 times a negative 5 will be a plus 15. 10 plus 15 is what? 25. And the square root of 25 is 5. Does 5 equal negative 5? No. So this, we came up with a false statement, which means that x equal negative 5 is our extraneous solution, so we can cross that out. And also, to be on the safe side, let's check for x equals 2. Again, using the original equation, we got the square root of 10 minus 3 times x, which is 2. Want to know if that's going to be equal to 2 when I simplify it. 3 times 2 is 6. So I got the square root of 10 minus 6 equaling to 2. 10 minus 6 will be 4. And the square root of 4 is 2. Does 2 equal 2? That's a true statement. So that means that x equals 2 is the actual solution for that radical equation. Are there any questions about problem number 7? Okay. Now, problem number 8 deals with just solving a polynomial equation. And with this one, you'll have to do some factoring here in order to solve that. So here in problem number 8, we got x cubed plus 12x squared plus 35x equal to 0. And in this case here, we're going to need to factor this polynomial completely. Let's see. What is the common factor that's in x cubed, 12x squared, and 35x? The x. So let's factor out the x. And we're going to divide every single term by that common factor. So x cubed divided by x will be x squared plus 12x squared divided by x. 12x plus 35x divided by x. 35. That's going to be equal to 0. Now we got x squared plus 12x plus 35 that can be factored into two binomials. Notice I'm bringing down the x. Let's see, x squared breaks up as x times x. And what factors of 35 gives me 12x as a middle term? 7 and 5. So it'll be x plus 7 and then x plus 5. Because the middle term is plus and the last term is plus. So factor completely, I get x times x plus 7 times x plus 5 equal to 0. And then we set each individual factor equal to 0. So this means that x will be equal to 0, x plus 7 is equal to 0, and x plus 5 equals 0. Well, in this case here, x equals 0 is already solved for x. Now for the x plus 7 equals 0, what must x have to be equal to? Negative 7. And then for x plus 5 equals 0, what must x have to be equal to? Negative 5. So for this polynomial equation, I have three solutions here. 0, negative 7, negative 5. So that's how we solve this polynomial equation. So on one side, you want to get a 0 on the other side by moving terms, and then factor completely. And then set each factor equal to 0 and solve. Any questions about problem number 8? All right, now problem number 9 is one of those equations with a rational exponent in it. Here you got 5x to the 3 halves minus 40 equal to 0. Now off to the side, what I would suggest is to determine whether you need to use a plus or minus symbol, and also whether you need to check your proposed solution. That exponent there is 3/2. The numerator of the exponent is 3, even or odd? Odd. So when your numerator is odd, you do not need a plus or minus symbol. If it was, then you would have to use that plus or minus symbol. The denominator is 2, even or odd? Even. For if it's even, you must check your proposed solution. If that denominator is odd, then pretty much if it's even, you check your proposed solution. But for odd, you don't check your proposed solution. That's what I was trying to say. All right, so now let's solve this equation. Let's get that 5x to the 3/2 by itself by doing what? Add 40. So that means I have 5x to the 3/2 equals 40. And now to get x to the 3/2 by itself, I need to do what? Divide by 5. So here you got x to the 3/2 equals what? 8. All right, so now to solve for x is being raised to the 3/2. What would be the reciprocal of 3/2? 2/3. So I'm going to raise both sides of this equation to the 2/3 power. And this 8 would be to the 2/3. So that means here, 3/2 times 2/3, if you multiply those exponents, since we're raising a power to a power, that's going to be a 1. So you're left with an x to the 1 or just x, and that's equal to 8 to the 2/3. But let's simplify 8 to the 2/3. And I'm going to use my calculator to do this. Clear this out. If you type in 8 and then press this hat key that's right below the clear key, and then do 2 divided by 3. That'll give you the answer of 4. So my proposed solution is x is equal to 4. Now here we don't need the plus or minus symbol. However, we need to check our proposed solution. I'm going to rewrite the original equation and then substitute the x with the 4. So it'll be 5 times 4 to the 3/2 minus 40. Well, note that's equal to 0. Now I have 4 times, and I'll go ahead and do 4 to the 3/2 on the calculator. So it'll be 4, then the hat key, 3 divided by 2 would be 8. So I have 5 times 8 minus 40 equal to 0. And then 5 times 8 is 40. Now what's 40 minus 40? 0. And 0 equals 0, so that checks. So that means x equals 4 is the solution to that equation with rational exponents. Okay. Are there any questions about problem number 9? All right, number 10 is using an appropriate u substitution for this equation. X to the 4th minus 13x squared plus 36 equals 0. Okay, so here we have to use an appropriate u substitution. So what that means here is this: we're going to let I'm going to let u equal to the variable of the middle term. So here's the middle term right here. That variable is x squared. So I'm going to let u equal x squared. And then I'm going to square both sides of this equation. We're going to square both sides of this equation. So u and we squared will be u squared. That's equal to, when we raise a power to a power, we multiply the exponent. So what's x squared? And we square it. X to the fourth. Okay? Now we're going to substitute into this equation. We're going to substitute u and u squared into this equation because our equation is going to be in terms of u. Now, x to the fourth, that's the u squared. Minus 13 times this x squared, we let u be x squared, so it would be 13 times u plus 36 equal to 0. And now let's go ahead and factor this into two binomials here, if at all possible. U squared breaks up as u and u. What factors of 36 gives me negative 13u as a middle term? Negative 9 and also negative 4. They both have to be negative. The middle term is a minus and the last term is a plus. So both the 9 and the 4 have to have a minus sign in front. So it'll be u minus 9 times u minus 4 equals 0. Then we set each binomial factor equal to 0. So this means u minus 9 equals 0, or u minus 4 is equal to 0. And then the next step would be to solve for u. Well, for u minus 9 equals 0, u has to be equal to 9. And then for u minus 4 equals 0, u has to be equal to 4. Now we do the back substitution. Because we started off with an equation in terms of x, we must have solutions that are in terms of x. Here we let u equal x squared, so we back substitute the u with x squared. So it'll be x squared is equal to 9, or same thing here, x squared is equal to 4. Each one of these will solve for x. What's the opposite of squaring the x? Take the square root and include plus or minus. So that means x is equal to plus or minus square root of 9 is 3. Or, same thing here, take the square root on both sides for that x squared equal 4 and include that plus or minus symbol. X will be equal to plus or minus the square root of 4 is 2. So in this case here, I have 4 solutions for this equation. Positive 3, negative 3, positive 2, and negative 2. So those are my 4 solutions for this equation that's quadratic in form. And that you have to use the appropriate u substitution there. Okay. Are there any questions about problem number 10? Okay, problem number 11 is an absolute value equation. So here we got the absolute value of 3x plus 5 minus 2 is equal to 6. So here we're going to solve this absolute value equation. Well, first of all, we need to get the absolute value by itself. By doing what? Adding 2 to both sides. So here I got the absolute value of 3x plus 5. Absolute value of 3x plus 5 is equal to 8. Now, since the absolute value is by itself, I can go ahead and write my two equations here. So the absolute value of 3x plus 5 equals 8 means this. 3x plus 5 is equal to positive 8, or 3x plus 5 is equal to negative 8. And then for each equation, we will solve for x. So for the 3x plus 5 is equal to 8. That means 3x is equal to 3. Divide both sides by 3. X is equal to 1. And then for the other equation, 3x plus 5 is equal to negative 8. I still need to subtract 5 on both sides. But 3x is equal to what? Negative 13. Divide both sides by 3, and I will leave this as an improper fraction of x equal negative 13 thirds. So my two solutions for this absolute value equation would be 1, and the other one would be negative 13 thirds. Okay. Any questions about problem number 11? All right, number 12 through 15, we know we're going to have to write the solution set in interval notation. Also, we're going to have to graph the solution set on a number line. You'll be provided number lines on your exam. So in problem number 12, it's just a regular inequality. Here we got 3 times the quantity x plus 7 then minus 12 is less than 5x plus 1. Okay, so now let's go ahead and solve this inequality. If I distribute the 3 over the x plus 7, I would get what? 3x plus 21 minus 12, and then that's less than 5x plus 1. Now, combining like terms, what's 21 minus 12? 9. So I bring down the 3x plus 9 is less than 5x plus 1. And now let's put the variable on the left-hand side. So let's move that 5x over to where the 3x is by doing what? Subtracting 5x. I mean, you could, but let's subtract 5x. Now, what's 3x minus 5x? Negative 2x plus 9 is less than 1. And then to get negative 2x by itself, I need to subtract 9. So negative 2x is less than 1 minus 9, negative 8. And then divide both sides by negative 2. But what's going to happen to that less than symbol? We're going to flip it from less than to greater than. So the x is greater than 4. Now we need to graph the solution set on a number line. And again, you'll have number lines on your exam. Let's say 0 is here. For 4, do I need parentheses or brackets? Parentheses, because it's strictly greater than. So I'm going to use a left parentheses at 4. And that greater than symbol points to the right, so that means we need to shade to the right. Okay. And the interval notation, you'll need to include that as well. The 4 has the left parentheses, so before. This goes indefinitely to the right, so it would be positive infinity. So that would be the interval notation for this solution set, 4 to infinity. And of course the graph is included as well. Make sure that you do the graph and write the interval notation as your answer. Questions on number 12. Don't worry about set building notation, just interval notation. Okay? Any other questions? All right, problem number 13 is a compound inequality. Here we got negative 2 is less than or equal to 3x plus 4 and less than 6. So that means we have to perform the same operation on the left side and in the middle and on the right side. So what do I need to do first for this compound inequality? Let's subtract 4. Subtracting 4 on the left side, subtracting 4 in the middle, and subtracting 4 on the right side. So here, negative 2 minus 4 would be negative 6. And that's less than or equal to, we have the 3x by itself, and then less than 6 minus 4 is 2. And now I still need to get x by itself, so I need to do what? Divide the left side, divide the middle, and the right side of this compound inequality by 3. So negative 6 divided by 3 is negative 2, and that's less than or equal to x, and less than, and I will leave that as 2/3. So this is my solution set for this compound inequality. X is greater than or equal to negative 2 and less than 2/3. And of course the graph. Say 0 is here. Is negative 1, negative 2. 2/3 is about right here. For the negative 2, do I need a bracket or parentheses? A bracket. And what about the 2/3? Parentheses. So left bracket at 2, negative 2. A right bracket at 2/3. And to indicate that all the values of x are in between negative 2 and positive 2/3, we shade in between. Okay? All right, questions on problem number 13. All right, problem 14 and 15 are absolute value inequalities. Oh, I'm sorry. Thank you. What would be the interval notation for this? A bracket at negative 2 and 2/3 right parentheses. Thanks for catching that. All right, any other questions? All right, now problem number 14. Now 14 and 15 deals with absolute value inequalities, and your inequality symbol will tell you which case you're going to have to use. So for problem number 14, I have the absolute value of 3x minus 1 is greater than or equal to 5. Now, with the greater than symbol, and the absolute value is already by itself, I'm going to tell you that now, we need to write this as two separate inequalities. This is just for greater than or equal to. Since we got greater than or equal to here, we need to write this as two separate inequalities. The first one will be 3x minus 1 is greater than or equal to 5. The other one will be 3x minus 1 is, and we switch the inequality symbol from greater than to less than or equal to. Positive 5 changes to negative 5. And then we get x by itself for each of those inequalities. So starting with 3x minus 1 is greater than or equal to 5, we need to first plus 1 on both sides. So 3x is greater than or equal to 6. Divide both sides by 3x is greater than or equal to 2. And then for the 3x minus 1 is less than or equal to 5, you'll still add 1, but now 3x is going to be less than or equal to what? Negative 4. And then divide both sides by 3. X will be less than or equal to negative 4/3. Okay? That's my solution set. Now for the graph of the solution set on a number line. I'm going to say negative 4/3 is on the left, and 2 is to the right of that. Now for the x is greater than or equal to 2, do I need a bracket or parentheses? Bracket at 2. And it says greater than or equal to 2. So which direction do I need to shade? To the right, because that inequality symbol points to the right, you shade to the right. Now for the x is less than or equal to negative 4/3, again, bracket or parentheses. This time a bracket, but this time which direction do I shade? To the left of negative 4/3. So this is what my graph looks like. Now for the set builder notation, not set builder, interval notation. Going from left to right, this negative infinity up to what? Negative 4/3 with a right bracket. And then I'm going to use this union symbol. The other one will be to positive infinity, because this goes indefinitely to the right. That's how you write the interval notation for this. Any questions about problem number 14? And finally, problem number 15. Another absolute value inequality. This time you got the absolute value of 7x minus 5 is less than 9. Now, since my inequality symbol is by itself, I do have less than. Less than or less than or equal to means I need to write this as a compound inequality. The compound inequality for this would be, take that 7x minus 5, which is inside your absolute value symbol. That would be in between the two less than symbols. The 9 on the left side would be negative. The 9 on the right side would be positive. So this is going to be the setup for this. Negative 9 is less than 7x minus 5 and less than 9. And then we're going to perform the same operation on the left side and in the middle and on the right side. So I need to start off by doing what? Add 5 on the left side, add 5 in the middle, and add 5 on the right side. So negative 9 plus 5 will be what? Negative 4, and that's less than 7x, and less than 9 plus 5, 14. And now to get the x by itself, I need to do what? Divide by 7 on the left side, divide by 7 in the middle, and divide by 7 on the right side. And I'm going to leave this as negative 4/7 is less than x, less than 14 divided by 7, 2. So that's my solution set for this compound inequality. Now, the graph, and I'll give you the interval notation as well. Okay. Let's see, 0 is here, 2 is over here, Negative 4/7 is a little bit to the left. Now on negative 4/7 and at 2, do I need brackets or parentheses? Brackets. This time my endpoints are not going to be included. Okay, I mean parentheses. Parentheses. The endpoints are not going to be included. Now, to indicate that x is in between negative 4/7 and positive 2, we need to shade in between. And then my interval notation, of course, negative 4/7 has a parentheses, so does 2 has parentheses. So that is the interval notation for that. All right, any questions about what will be on your first exam? All right, let me go ahead and remind you